these papers had been turned in on time, then I would have had them back to you right when, as soon as they were turned in. So we'll go from the current slide and I do not see. Oh, there it is. There we go. Okay. Let me mark Alexius here. Okay. Now, Alexis, if you'll stop right after class, I'll get you your papers. I've already returned those to people, so I don't want to go through that again. Okay. Let's talk first, before we start back into the pre-calculus algebra, how things are going to play out now. If you haven't gotten all your papers back, come see me between 11:15 and 3:15, and I will, okay, this is not good. Okay, it should be projecting, and it's not. I swear somebody, okay, JT's here. Okay. And JT, I've returned papers to people already, but I'm not going through it again, so you can see me right after class between 11:15 and 3:15 today, and I'll get them back to you. Okay? And try something. Do you see an input button there? Different projections in different ways. That's not what I want. That's not doing anything. I can't read this, so maybe it'd be better to use this. So I don't see that anything's working, so it must be the cord. And well, they don't have this tight here, but that's not changing anything. They have it all wiggled up. Should have done this before y'all got here. I was focusing on getting papers finished. There we go. There we went. Bang on it, and that'll work. Okay. I forgot the rule number 1 for operating machinery. Electronics. Doesn't work right, hit it. Okay. No, that's students. I'm getting confused. Okay. All right, let's talk about our end game. We're going to finish as much as we can in Chapter 3, Section 3.1, hopefully get to 3.2. And then on Tuesday morning, 8:30, is that what y'all understand? Tuesday morning, 8:30, we'll be right back here again, and you'll have your final exam. It'll be in 2 parts. Actually, it's only 1 part of the final, but the first, it's going to be less than an hour, will be your Chapter 3 test. It's going to be very simple, very short, and that'll cover Chapter 3, okay? And then, hopefully it'll be sweet as well, but okay. Then, when you finish that, you can start the comprehensive final, which will be a single page, not 2 pages like your first test was, and probably only 10 questions, and it's stuff you've already had, okay, so you should do fairly well on it. Your previous test, that's why I wanted them back to you, and quizzes, would be great things to review for that, and you'll not see the same questions, but you'll see similar type stuff on that, okay? So that's why I want to know, are there any questions on any of those quizzes or tests, things you don't know why you missed? Now, you're working on a test now? Why don't you go down to, in case there are any questions, I don't want to keep people from asking. You know where 201 is? Yeah, down the hall. Not far down the hall, it's just a short distance. Next door is 203, the very next thing is 201, just the side of the green block. Yes, ma'am. I'm sorry? Yeah. I can't hear you. Yeah, today's the last day of class. Tuesday is your final exam. Okay. Yeah, that's the last time. Yes.
There was one question that I don't even remember going over. It was number 3 on the second test.
3 on the second test. Let me find the second test.
Maybe it was just the wording or something.
Okay. Test 2. Okay. I'm sorry. Okay. Fine. Going up here. Test 2. Okay. You need graph paper? Okay. You can use formula and equation sheet, scratch paper, calculator. Okay. Now, number 2. I just had it. I set it aside for now. Number 3. Okay. It's not one that we did, but it's sort of a word type problem that uses what we have. All right, you finished? Good deal. Okay. All right. And since everybody has done it, right, let's see what that produces. Okay, let me get my pen set up. Okay. Here we have it. Find 2 positive real numbers whose product is a maximum and whose sum is 156. Okay? We need 2 numbers. Pick a variable to be one of the numbers. What you want? X? Did I hear X? Okay. So let X equal one of the numbers. I can't write. Okay. Now, let's read it again. Find 2 positive real numbers. Now remember, they're positive. Okay? Positive real numbers whose product is a maximum and whose sum is 156. Okay? So what might be the second number? Hint. Whose sum is 156. You want to name a variable for the second number. You can do that. Y, okay. And Y is equal to the second number. Is that okay? All right. Now, let's go back to that second phrase. Whose sum is 156. How could you write that in a mathematical sentence? x plus y is equal to 156. Got it? Okay. Now, let's solve this for one of the two variables. I don't care which one. Which one you want to solve for? Y. Okay, so we're going to solve for y. So what are we going to do to solve for y? Subtract x from both sides. I'm going to put it right. Oh, goodness gracious, what are you doing? Okay. Subtract x. Why is this not writing? Okay, let me get my pen back again. There we go. No, it's still not writing. Okay. Goodness gracious. I don't know what it's doing. Can you? Yeah. Okay. The pen. Okay. As soon as it gets up there, it goes to being a pointer or something. Okay. I don't know why it's not writing. Okay. There we go. All right. So here the x's go away, and you have y is equal to what? 156 minus x. Something about this part of the board it is not going to write on, and I do not know why. It wrote on it up here. Okay. So I'm going to erase that and scoot it over. Okay. Y is equal to 156 minus x. By that? All right. Now let's go to the first sentence, first part of the sentence. Find two positive real numbers whose product is a maximum. Well, here's one, and here's the other. Oops. Here's one, and here's the other. So how do we write the product? It's not that hard. How do we write a product? What does product mean? Multiply. So here's one number, x times 156 minus x has got to be a maximum. Okay. Now, okay. Okay. Let's multiply through. What do you get? 156x minus x squared is equal to some max, right? Now, what kind of if that was some number, and it will be some number, what kind of equation is this? Maximum exponent 2. Quadratic equation. Okay? And what will be the maximum on a quadratic equation? What's the shape of a quadratic equation when you graph it? A parabola. And how will this parabola look? Opening downward. Okay? And what will be the vertex? It's going to be your second?
The maximum.
The maximum, exactly. Okay? And you remember how to find that vertex in the shorthand notation, not without doing the other thing. What was the vertex, the x value of the vertex, which we call h? Little formula we had. If you got your books open, oh! I hate it when it does that. Okay. Thank you so much. Appreciate it. Okay. I'll put these underneath and hopefully they won't fall again. Okay. Y'all don't remember that one, huh? This is the thing really needed big time to remember. Okay, this is .1, I'm pretty sure. We had the leading coefficient test. Okay. Oh, I'm in 2.2. That's why I couldn't find it. 2.1. All right. Back on page 119. Finding the minimum and maximum values. Okay? When, and that little block they have there, number 2, when A is less than 0, which it is, it's a -1, it has a maximum at what x value? Negative b over 2a. Okay? So that might mean that we have to figure out what a and b are here. What are a and b in this problem? I'll write it in a different way. Minus x squared plus 156x is equal to a max. Okay? Okay, so you said minus, what is an h or x equal to? Minus b over 2a. And your b you said was what? Ah! Okay. B was what? B was what? Okay, what was A? Really? Okay, B is 156 over 2A. A was -1. Yeah. Okay. Over on the border again. So this is minus over minus is plus. 156 over 2 is equal to, say again, 78. Okay? All right. Good deal. Up all night working on her paper. Okay. No. Okay. All right. And then how do you get what y is? How do you get what y is? Yes, 156 minus x, that gives you your y. Okay? Yes? I'm sorry? It was off the second test. I asked if there were any questions. Okay? Now let me get the folks who have just coming in. Okay? All right. Zaria hasn't come in yet. Kiara is Treese. Okay. I think I've already marked her here once. There's Treese. Yeah. Okay, Treese is here. Let's go down. Kiara, not here. Good. Breath in front of the line. Jakaya come in? No, I don't think so. Walt, Christian, Tyler, Alexis, no. 3, daughter, Regan, no. Z, did Z come in? No. Treese did. Jalen came in. Okay. Demetric, Michaela, Ron, Alexius. Amaya? No. Oh wait, Reggie came in. I didn't mark him. Ashley came in. I didn't mark her. And did I get... Got JT. Did I get Ryan? No, I didn't get Ryan. Okay, I think one other person came in since I called roll. Anybody? Not? Okay, maybe I got Alexius. Did I get her? Yeah. Okay. Did I get everybody on the roll? Okay. Okay. That answer your question? So it was using stuff that we did, but it just in the form of a word problem. Okay. All right. Let's get rid of this ink. Any other questions before we move on? And for those who came in late, I have most of what you turned in yesterday, or turned in graded. A few things I just did not have time to grade. I think 4 papers I didn't have time to finish grading. I have to get those back to you when you, preferably between 11:15 and 3:15, because I have class right after this. But all your papers are up here that I did get graded. If you came in late, see me either preferably between 11:15 and 3:15, because I've got class right after this, and they'll be waiting for me down there. So if you can, come between 11:15 and 3:15 and pick up your paper that that I went through this morning. I gave out everybody's. Okay? Now, let me just check. I put a few sides here. He's still taking a test. Okay. Any questions on anything so far? So I was going over this before. Some of you came in, so let me say it again. Tuesday morning at 8:30, same time as normal, we meet here for your last test and your final exam. Okay? The last test will be on Chapter 3, what we get covered so far by the end of the day. And then the comprehensive final, both of them will be very short. You can easily finish either of them in less than an hour. So you've got an hour and 50 minutes to get both of them. So it doesn't go just till 9:45. It goes till 10:20. It's an hour and 50 minutes you have for those 2 tests. You should be able to get them done without any sweat. If you need more time, you can have more time, just like always. I don't have a test following this. If we can't stay in this room, we'll find another room. 255, I know will be open. Okay? Any questions? Okay. Research papers have to be in today. Okay? And if there's those who came in late, or any of you haven't finished the test or turned in a quiz. All of you have done everything, right? Okay. Then y'all can pick it up between 11:15 and 3:15 today. All right. Now, where we left off last time was Example 7, Chapter 3, Exponential and Logarithmic Functions, 3.1, Exponential Functions and their Graphs, and Example 7, sketch the graph of each natural exponential function. And let me write this down. I wish I had more room here. This is such a pain. Here's the first. All right. F of x is equal to 2 times e to the 0.24 x. Okay? And we're supposed to graph this. All right. Let me check off a few points here. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5, 6. Okay? And again, the pen's not writing to the right, and I don't know why. Okay. Give me an x. 0. Okay? And 0 times 0.24 is 0. E to the 0 is what? Is it 1? And then 2 times 1 is 2. Okay? Okay. So at 0, it's equal to 2. Now, y, we've been saying it always is 1. No, this had 2 multiplied out, so it's 2 times 1. Give me another x. 1. 0.24 times 1 is? Easy. 0.24 times 1? 0.24. E to the 0.24. Pick up your calculator, do it. E to the 0.24. Not that hard. All of you, okay. When you're taking a test on this chapter on Tuesday, you've got to know how to use your calculators. Okay? So if you're having trouble with it, let's get that cleared up now before Tuesday morning. Okay? So what is e to the 0.24?
1.271.
And double that?
2.54.
2.54. That would be somewhere right around there. Okay? Give me another x. 2. 2 times 0.24 is? Easy math. 0.48. E to the 0.48? 1.6 something. And double that?
Yeah, 1.6.
Okay, and double that because of the 2 here? 3 point what? Okay, 3.2 something, so that would be right about there. Okay, are some of you having trouble doing it? Okay. All right. Give me another x. Second?
We already used 3.
3. Let's do 3. 3 times 0.24 is? 0.72. E to the 0.72 is? Double that? 4.1. That's right about there. Okay? Give me another x. Second? Give me another x. Did someone say something? I can't hear well. 4. 4 times 0.24 is? 0.96. E to the 0.96 is? Okay, and double that? Okay, 5.2. So that would be somewhere about there. Okay? Let's do the next one. I don't know if I'll be able to graph it. 5. 0.24 times 5 is? Second? 1.2. And e to the 1.2 is?
3.3.
And double that?
6.6.
Is what? 6.6.
6.
Okay, is that what you said? Okay. 6.6. That's somewhere up here. I don't think it's going to plot, but you get the general idea. It's going like this. Okay? Let's do some negatives. When x is negative 1, 0.24 times negative 1 is? 0.24 times negative 1 is? Negative 0.24. E to the negative 0.24 is?
0.78.
And double that? 1.4 something, okay? Negative 2. 0.24 times negative 2 would be negative 0.48, right? E to the negative 0.48 is? 0.6. Double that? 1.2, okay? E to the negative 3, use x equal negative 3. Huh? Okay. X to the negative 3, negative 3 times 0.24 is negative 0.72. E to the negative 0.72. And double that? 0.97. Okay? Thank you. Okay. 0.97. Okay? Let's try 4. Negative 4. That would be negative 0.96. E to the negative 0.96 is? 0.38. Double that? 0.76. Somewhere around there. Let's try negative 5. That would be negative 1.2, right? E to the negative 1.2. Second? Okay, double it. 0.6, okay? Okay? And you should get the general flow there too. There's what e to the minus, 2e to the 0.24x looks like. Okay, was everybody able to follow? I know we're going sort of rapid fire here. Anyone having problems with this? Seeing how you plot it? Okay? Let's try the B part. Ooh, yeah, it's okay. Here's the B part. What color you want B to be? B to be? Blue. Light or dark? Light? Okay. This is g of x. Can you read that okay? Is equal to 1/2 e to the negative 0.58x. Okay. Guess where I'm going to start? Give me an x. 0. And 0 times negative 0.58. Still 0. E to the 0 is? Is what? Okay. 0. E to the 0 is? 1. And 1/2 of 1 is? 1/2. Okay, here we go. That 0, we're down at 1/2. Okay? X equal 1. 1 times negative 0.58 is negative 0.58. E to the negative 0.58 is? E to the negative 0.58. 0.5, and half of that is 0.25, isn't it? Something around there? Okay. How about when x equal 2? Negative 0.58 times 2 is like negative 1.16. Okay, e to the negative 1.16. 0.31, half of that is 0.15. Okay, we're down here in the graphs here. It's getting small very, very quickly. Let's go to the negative side. When x equals negative 1, negative 0.58 times negative 1 is? Is what? 0.58. And e to the 0.58 is? 1.7. Take half of that. 0.89. Somewhere about right in there. Okay. How about negative 2? Negative 2 times negative 0.58 would be negative 1.16, positive 1.16. E to the 1.16 is? And half of that is? 1.59. Somewhere about here. Okay? X equal negative 3. Negative 3 times negative 0.58. And e to the that. And half of that. 2.84. Somewhere about right there. Okay? X equal negative 4. Negative 0.58 times negative 4 is? Okay, e to the that is? And half of that is? Is what? 5.08? Okay, I thought you said 7 point something. Okay, 5.08, so it's somewhere up here. So you get the general idea? It's coming down like this and then approaching 0 very rapidly. Okay, there we have the graphs of, just as a reminder, E's a number around 2.7 or so. It's an irrational number, so you can't say it exactly. You raise that to a positive power, and it's always going to be increasing. Raise it to a negative power, it's always going to be decreasing. Okay? The coefficient in front just doubles it or halves it, whatever the value would be. It doubles it or halves it. So that's why your intercepts are no longer at 1, because this is a vertical stretch. Yes, sir.
I'm confused with
description of the right and the left hand being greater than.
Okay, say that one more time.
You talking about the right hand, left hand being greater than.
Oh, okay. Let's talk about this. What's the right-hand behavior of the black graph? As x gets increasingly large, like going to positive infinity, what's f of x doing? Way going to positive infinity, very rapidly. As x is going to, for the black graph again, x going to negative infinity, what's your f doing? Nope. Getting closer and closer to?
Negative.
Getting closer and closer to? 0. Yes. Okay. Let's do the blue graph. Okay. That's not blue grass, blue graph. Okay. Light blue graph at that. Okay. G of x as x goes to positive infinity. Where's the function going? To 0. And as it goes to negative infinity, where's the function going? To what? To positive infinity. Perfect. As x goes to negative infinity, g of x is going to positive infinity. See what we mean by that? Okay, we usually talk about it in terms of polynomial functions, but here exponential functions you can use the same references. Okay? With polynomial functions, all four of those answers are going to be some type of an infinity, okay? With exponentials, no, one's going to 0, always. Or, yes.
What's a multiplicity?
What's what?
What's a multiplicity?
Simple.
He said, what's a multiplicity?
Oh, what's multiplicity? Okay? Now, this doesn't have any, because what multiplicity is referring to is when you have a polynomial function that, say, touches the x-axis here and crosses it. Right. Good deal. Thank you. Okay. Oh, wait. That was your first quiz and first test. I haven't got the second quiz graded yet. No. Okay. Now, let's say we have a polynomial function. Now, let's say the polynomial function is a parabola coming down like this and crosses the x-axis here. Okay, just goes straight across. That's a multiplicity of 1. 1 and only one root. If it comes down and touches the x-axis here and then goes right back up, that's a double root. Okay? Okay? This is not the problem we're working on now, but let's say we have, what do you want to name the function? Give me a color first. Red, okay. All right, what do you want to name it? Well, we've already used f of x on this one. H of x. H of x. Now, I need it to be, let's just take a simple quadratic function, okay? Do you want a leading coefficient or not? What do you want it to be? 2, okay? And we already said x, and since we said quadratic, that's going to be squared. Okay, you want a plus or minus sign? Second? Plus, okay? Now, all right, let me get you marked here, okay? And also, I returned papers earlier this morning. Have you done all your quizzes and tests? Okay, everybody who came in late, have you done all your quizzes and tests? Everybody? Okay. Then if you want to pick those up, the best time to catch me today is between 11:15 and 3:15, because I passed them out earlier and I just don't have time to go through all those again. So between 11:15 and 3:15, I'll either be in 255 or 265. Okay. Now we're doing an example of a multiplicity of 2, okay? What's the next coefficient? Say again? I'd prefer it to be even. 8, okay? It won't right over here. This just drives me nuts. H of x is equal to 2x squared plus 8x. I'm going to come up with the other one. Get out of there. Plus 32. Okay, I think that'll work. Okay? Now, if you were going to find the zeros of that function, what would you do? Factor it. Okay, what would be the first factoring you would do? Factor out of 2. Okay, and that leaves you x squared plus 4x plus 16. Okay? Can you factor any further? Yay or nay? I heard a no or yay. I didn't hear. Will that factor any further? I think so, so let's try. If it doesn't, we'll come back and do something else. If it would, what has to be the first factor? X times x. Okay? And then we look at the sign of the last term. That's positive. That means these two signs have to be the same. What sign does that have to be? Plus. So plus and plus. And what would be one guess for what a possible factorization of 16 would be? Okay, pick one. Say again? Help me. I can't hear. Try one. 4 and 4. Is that right? Oh, I did blow it, didn't I? I picked the wrong number. I wanted that to be 16. Sorry. Nope. Wait. I want it to be 4. No, I want it to be 8. Okay. That makes this 4. Okay. Sorry about that. What will that be then? 2 and 2. All right. That's better. I was trying to do it on the fly, and that's not a good idea this early in the morning. 2 times 2. Okay? What would be the roots of that equation then? The zeros of the equation. X equal negative 2 and x equal negative 2. Hey, we got 2 zeros there. There's one and there's another. Okay? And this parabola comes down like this. Okay? It comes there and kisses the x-axis there. It's a double root. Okay? This is for a quadratic anyway. Okay? Now, that means this 0 has a multiplicity of 2 because there's 2 roots there. Okay? Now, if we had a cubic function that came down and did this number, okay, it came down, touched there, it could have 3 roots there. Then that would be a multiplicity of 3. X equal 3, x equal 3, and x equal 3, okay? If you had a quartic function that came down and did this number, that would be x equal negative 4, negative 4, negative 4, and negative 4. That would have a 4 roots there. That would be a multiplicity of 4. Unless you factor it, exactly. And all those that I asked for that was the first thing you did, was factor them. Okay? And if you had multiple zeros for the same value, then that was a multiplicity of whatever that was. If you only had one value, multiplicity of 1. Just going down there and cutting right through. Okay? Any other questions? All right. Now let's get back to, we just did example 7. Any questions on example 7? That was the black and the blues here. That's the division that Chicago and Green Bay are in, I believe. It was the black and blue division. Never mind. That's professional sports. Never mind. Football. All right. No more questions there? Now let's go to, finally you get to do that. Okay. applications, which we love, okay? Here's one of the applications for exponential functions. If you are saving money or borrowing money, one of the most familiar examples of exponential growth is an investment earning continuously compounded interest or some other type of interest, or more likely, borrowing money at some type of interest. Now, this equation here is not for continuous, okay? This is for some rate. Give me an interest rate that you're either saving money or borrowing money at. Give me an interest rate. Second? 5%, okay, 5%. That would be your R, but you would write it as 0.05, write it as a decimal number. Did you say 8%? Somebody I thought said that. Okay, then that would be 0.08. That would be the rate. Okay, now if that rate was compounded frequently, how often do you want it compounded? Once a year, twice a year, 4 times a year? Second? Quarterly, okay? Then your N would be 4, okay? All right, now, and what NT would be the number of periods total. This would be 4 times a year times so many years. Okay. Your P would be how much are you saving the money or did you borrow the money? Saving it. Good man. Good man. Okay. That would be your principal. How much you put in the bank. How much would that be? How much did you put in the bank last month? $1,000. Good. Okay. Then this would give you the amount at the given rate after whichever quarter you did. 1 quarter later, 7 quarters later, whatever. That would be how you would calculate that. I'm sorry, I didn't say that quite right. If this was quarterly, this is a 4, that's a 4. If it was 7 quarters later, then that would be 1 and, let's see, then this whole number would be quarterly, so that would be divided, it would be 4 times, yeah, well, no, 4 times how many years? So that's 1 1/4 year. That would be 7 quarters, and 4 times 7 quarters would be 7. Okay? All right. Are you ready for test 2? Okay. Let me get it for you. Do you need graph paper? Okay. Okay. And the others are in room 201. So that's just down the hall here. You know where 201 is? Mm-hmm. You do know. Okay, just that lecture room. Okay, okay. Because yeah. So as far as I know, there's no class in 201. Just before the green light. And when you finish, be sure you return the calculator. All right. So that's how you would do this. T is the number of years, and 7 quarters would be 1 3/4. Yeah, 1 3/4. So it would be 1.75 years times 0.25. That would come out 7. So this is the number of quarters. Okay. NT would be the number of quarters. All right. So that's what you would be doing. And so you can plug it in whichever quarter you're receiving your statement. After you put that in, this tells you what your interest rate, what your total amount would be. Not the interest, but the amount. Okay? Second? It could be, because we're going over it in class. Okay? Let's see if we do a problem. Okay? Using exponential notation, by the way, that was using exponential function, you can develop this formula and show that it leads to a continuous compounding. Suppose you have a principal P, you said 1,000, annual interest rate R, you said 5%, compounded once a year, so that would be, your N would be 1, and this would be number of years, okay? They're sort of going backward here, but this would be the new balance here, would be your original principal plus principal times your interest after 1 year. After 2 years, and you can factor out the P, 1 plus R, and here's where you divide by 1, because it's once a year, and multiply and raise it to 1. So not a very interesting problem there. Okay. After 2 years, it would be the same thing, P. This is how they derived that formula they just did, but this is for compounded once a year. Okay. To accommodate more frequent, like quarterly or monthly, daily compounding, you get this. This is the same thing we had before. So no reason to do. Now, what about continuous compounding? Okay? That's not once a second, you know. Now let's just go over quickly. If you were doing quarterly, you put a 4 here, and 4 times how many years you have in terms of quarters. Okay? So this is number of quarters up here. If you did monthly, this would be a 12 here, and 12 times the number of years would be how many months you were. If you did it, what would be another? Daily, then you would be 365 times a year, and this would be 365 times how many years, so it's, in other words, how many days you had it. So this is getting to be a bigger and bigger number here and a much bigger and bigger number here. With continuous compounding, later you'll learn to take a limit. We're not doing limits now, but this is what it comes out being. Okay? I guess that's next door. This is really a weird way to do this, but it's perfectly okay. And we don't have a lot of time to go through this. Let's just cut to the chase and show what happens. Here's what you get when you're doing continuous compounding. So much simpler than any of this. This number right here that they were getting to leads you to the number E. If you do this thing right here and just enter bigger and bigger numbers in here, 10, 100, 1,000, 10,000, 100,000, a million, 10 million, you're getting closer and closer to this number right here. It keeps getting closer to E. That is your base of your. Someone on your calculator do E to the 1 and see what you get. Okay, you see you're good to 1, 2, 3, 4, 5, 6, 7 digits there. Take it up to 100 million, I bet you get another digit or 2. So you're getting closer and closer to E. Okay? So here, that thing that we wound up doing, here's how you do continuous compounding. A is equal to principal P E to the RT, where R is your interest rate and T is how many years you've had at that rate. That gives you continuous compounding. Why in the world a bank or any institution would use anything other than continuous compounding beats me. It doesn't save them that much money, but the calculations are so easy to do. Okay? Seems like it'd be so easy to set up and go. Okay, I'll take it by the activity. We must be near the end. So we didn't get to do anything beyond that, but let me tell you what some typical homework exercises could be. Any of the odds, 7 through 11, they're all at Calc Chat, 7's at Calc View. Any of the either 13 or 15, they're both at Calc Chat. Frankly, I would do all 4 of those, but only those 2 are at Calc Chat. Any of the odds, 17 to 23, they're all at Calc Chat, 71's at Calc View. 25 or 27, they're both at Calc Chat, 25's at Calc View. Any of the odds, either 29 or 31, they're both at Calc Chat, 29's at Calc View. Either 33 or 35, they're both at Calc Chat, 35's at Calc View. 37 or 39, 37's at Calc View. Either 41 or 43, both at Calc Chat. 45 or 47, both at Calc Chat. 49 or 51, both at Calc Chat. 49 at Calc View. And compound interest, 53 or 55, both at Calc Chat. Then any of the odds, 57 through, wow, 65. Okay, try any of those. They're all at Calc Chat. There's a true false at 67. You can try that. It's a true Calc Chat. 69 or 71 probably are there. You don't have to go there if you don't want to. I wouldn't worry with anything beyond that. Okay, test on this chapter, very short, very straightforward, pretty easy. Okay, and then your comprehensive will be mostly, I'm just going to give us 4 questions on chapter 1, 4 on chapter 2, 2 questions on chapter 3. Yes? Okay.
What sections will this be on? 3.1. This is 3.1.
Okay, the test is 3.1. Okay, the final will be 1, 2, and 3. 1, 1. Okay. Only the sections we did in those chapters. All right, good deal. Oh, has everyone done the student course evaluation? Please do the student course evaluation. Do you all know how to do the student course evaluation? Okay? You received an email, probably several emails. If you find that email, it has a link, go there, and it's pretty self-explanatory.
Every class?
Yes, you do one for all your classes. And they'll ask for a few more. Please do them.
I'll be back around 11:15.
Okay, maybe a 255 still, or a 265. Okay. Yes.
You got it.
What?
Okay. Yeah.
I'm gonna run into the library and go print my paper.
Okay.
I'll be to turn it in.
255.
Yeah.
Okay. Okay. Yes. Thank you.
Good.
Okay. I gave them out at the beginning of class. You can get them between 11:15 and 3:15. Okay. Is that okay? All right. Sorry about that.
You don't happen to have grades on the research papers yet, do you?
They're graded. I don't know if they're on Blackboard yet. Okay. If you want to see it, I'll let you peek. You see it? It's yours.
Nice.
Okay. Terrible. Okay. Yours.
All right. We'll see you
Okay.
Tuesday.
And yours. Shame. Okay. All right. You're good.
You said before I leave because I got to deal with Birmingham campus.
Oh, okay. All right. Okay. So you gave these out at the beginning of class. And I'm recording all this stuff.
You had to expect it.
I'm sorry?
I don't know if you said it up there now because you
Okay,
had
so here, here's your first quiz. Okay, I couldn't hear you what you said.
I don't know if you said it up there or not. Cause I had left out because I left on right side when this one I finished.
Okay.
So you put it back in the schedule.
No, I haven't graded that yet. Okay. Is that all you're waiting for?
And then I already gave you my research paper.
Okay. All right. Well, do I owe you anything else?
I got everything.
Oh, okay, right. You got
I
it
was
right.
here on the first
Okay,
day.
right. Okay. Yeah. Well, then,
You told me wait because you can grade it right now since I got on Birmingham campus today.
okay.
I won't be here between 2 and 3 because I got to go.
Okay. Well, I've got another class right now. Let me see. Okay. And all these people have put papers on top of it. And which was it? Quiz, test, or what?
Test 2.
Okay. Now, I don't have time to grade the whole test. I thought it was something that just was a couple more that you had to do. Okay. You're not going to be back on this campus?
Not today.
Not today? How about tomorrow?
I can come tomorrow.
Okay, I'll be in my office 265 tomorrow from 8 to 12.
Okay.
And I'm not on the Birmingham campus anymore on Friday because the building that got burned, that had the fire in it, they closed it. Okay, good. Thank you much. Sorry I can't get it done right now. Okay.
Okay, my research paper, I
But